Alright, so hello and welcome to another part of this tutorial on C. My name is Rohit Das, and in the last video we had spoken about variables, literals and assignment operators as well as arithmetic operators. In case you are wondering why I'm saying that I had spoken about assignment operators and I haven't, well actually I have, but I mentioned them wrong. So these were the assignment operators, right? Plus equal to, minus equal to, divide equal to. These five were the arithmetic assignment operators. Alright, we can normally assign variables just like this, but we can also use operators before the equal to sign, the assignment operator, so that we can reduce some of the code. So what this basically implies that it's a equal to a plus b. It's the same as this, alright, except we have to write less. Okay, we'll be using this operator a lot when we study loops, but for now we can simply use addition operators. Okay, today we'll be talking about relational operators, bitwise operators and logical operators, ternary operators as well, and hopefully we'll be able to enter into conditions itself, I mean in this video itself. Alright, so let's begin. So relational operators, they're nothing but they are there to show relation between two variables or two values, basically any kind of values. Alright, but they have to be compatible. The values have to be of the same data type. Okay, we can't compare an int with a string or a character, right? So we'll look into that, what can be done. Okay, so let's see what are the relational operators. We have the equal to, double equal to, which checks whether the value of a is equal to b or not. If a is equal to b, then it returns true. Alright, let's see with an example. Okay, let's take two variables, int a comma b. Let's say a equal to 5, b equal to 5. Okay, it's a no-brainer actually. Alright, so let's see, a equal to b. I'll be using this symbol to show the result, because otherwise you'll get confused between the operators. This is not an operator that we use in C. Okay, so we will be saved there, although I'm trying to print a string, but never mind. And then we're trying to print up some value, right? It will be an integer, I believe. Let's see, we'll be printing this. Alright, so let's save that and try to compile it. Alright, hopefully no errors. Alright, as you can see, it has printed 1. Let's put the escape sequence as well, so as to avoid the percentage symbol. Alright, so as you can see over here, it has printed 1. In C, 1 stands for true and 0 stands for false. So as you can see over here, it has printed true, because definitely you can see from here that a and b are equal. So what if they're not equal? As you can guess, it will output a 0. That's a no-brainer. Okay, next we have the not equal to operators. Alright, it looks like this. It simply checks whether a is not equal to b. Okay, guess what it's gonna print? Yep, it is gonna print 1, because a is not equal to b and this expression is true. So what it's actually doing is it's actually printing the result of this expression, the expression a not equal to b. Okay, so a not equal to b, this expression is true, right? When we are saying that a is not equal to b, some other person will say, yeah, it's true. If he knows the values of a and b, like if I have given a equal to 5 and b equal to 6, and then I tell him a is not equal to b, so the other person who is listening will say, yeah, it's true. So that's what's happening. Okay, we are giving it an expression and the output is the validity of this expression, whether this relation is true or not. Okay, next we have the greater than and less than operators. Okay, we have given a less than b. Is a less than b? Yes, it is. So hopefully it will print a 1, and it does. Okay, wait, sorry, I didn't change the operator over here. A bit confusing. Alright, so a is definitely less than b. Now let's change it to greater than. Okay, and let's compile that and check it. Alright, so a is not greater than b, a is less than b, and hence this comes out to be false. Okay, we also have the operator a less than equal to b. Okay, so a can either be less than b or equal to b. Okay, so let's see what happens. Alright, so okay, wait just a moment, I made a mistake over here. Okay, less than equal to. Alright, so as you can see over here, a less than equal to b results in true. Okay, let me change this. Just a moment, let me change this operator because we are soon going to use it. Simply use a equal to. Right, yeah, that will be better. Maybe results. Yeah, that's much more lucid. Alright, so as you can see over here, a less than equal to b results in true. Now what if I change a to 6 equal to b? What will be the result? That also results in 1, because less than equal to, as we know it, and the number a can hold any number less than b or equal to b, so that the expression results in true. Alright, let's check for greater than equal to b. Okay, the relational operators that we have in C, let's recap. So we have the equal to, not equal to, less than equal to, greater than equal to. Alright, so we use these to check the relation between two numbers. Okay, next we have the bitwise operators. Okay, so what bitwise operator does is, let's start with the type of bitwise operator that we have. We have AND, OR, and NOT. Okay, I mean XOR, sorry. So you have the AND operator, AND bitwise operator, OR bitwise operator, and the XOR bitwise operator. So I'll be going into what each of them do. Okay, so let's start with AND. We'll be using certain values, right? We'll be changing these values. Okay, first we'll be using 0 0 to start with, right, and then we'll be going into 0 1 1 0 and 1 1. So the combinations are like this: 0 0 0 1 1 0 and 1 1, the binary combination for 2-digit values in binary. Okay, so let's print the bitwise operation result. Okay, alright, so let's save that and see what happens. Alright, so as you can see over here, 0 and 0 results in 0. Alright, let's change the value of this to 0 1. Zero and 1 also results in 0. The result will be same if I change it to 1 0 as well. Alright, the only case where this output is 1 is when both of them are 1. Right, okay, so if we summarize the results, we can see that in case of AND, the only case where the output will be 1 is when both of the variables have 1 as their values. otherwise the output will be 0. Okay, so if you want a full chart of the outputs, you can simply Google it, the output of bitwise and it will show you a chart where all the two variables are used there, and they are operated upon by the AND operator, and the outputs are given. Alright, next we have these actually correspond to the bit operations in digital electronics. Okay, people who have covered digital electronics will know about AND, OR and XOR gates. Okay, the output is same, except that in case of instead of 0 we are using false, and instead of 1 we are using true. Alright, so I have used 0 and 1 over here. I will be showing what's the result when we use boolean variables. That's not exactly bool. Okay, and let's make them one false and one true. Okay, and let's check the output. Alright, true undeclared, first use what, unknown type name bool. Okay, well, that's odd. Okay, alright, let's keep it int, shall we? I don't think there are true and false available in C. They are available in C++, but we can't use them in C, I think. Yeah, there is no operator called data type called bool. We have to use 0 and 1. Okay, in C. Alright, so I hope you understood what bitwise AND does. It compares two bits. Okay, so this 0 and 1 are bits. Alright, bits in the memory. Next we have is the OR operator, OR bitwise operator. It's denoted by a single pipe. Okay, so here a bit, the output changes a bit in a way that the output shall be 0 only when both of them are 0. Right, and it will be 1 otherwise. Okay, so let's see what the output is. Alright, so as you can see over here, A and B is 0, and so the output is 0. Right, in all other cases it will be 1. Okay, similarly you can try it out for the other values. I won't go into them. You can do it for yourself and check it out. Alright, next we have the XOR operator. The thing with the XOR operator is that XOR is spelled XOR. Okay, that's stands for exclusive OR. Okay, like that. So that's XOR for you. Okay, so what XOR does is that it results in 1 only when the values are different. If they are same, it will result in 0. So let's see, A is 0 and B is 1. Let's see what the output is. Okay, so as you can see over here, the output is 1. Alright, let's change the operator over here as well. Alright, so as you can see over here, when they are different, it results in 1. But if they are same, let's make it 1, we'll see that they are different. I mean they are same, and the output will be 0. Alright, so we have covered bitwise operators and relational operators. Bitwise operators are simply there for bitwise operations where we compare two bits and get the output, whereas relational operators are used to compare whole numbers. Right, okay, so let me show you some examples where I'll be comparing values of different data types. Okay, so let's say A is int and B is double. Let's say A stores 10 and B stores 15.6. okay, sorry, wait. So the comparison will be A less than B. Right, I'll be doing only one type of relational operator just to show how to compare and whether to compare to different kinds of data types, right? Okay. Alright, so as you can see over here, the result is 1, and that's correct because 10 is less than 15.6. okay, so we can comfortably compare an integer number and a double number. Okay, but let's see what happens when we use a character variable. Okay, let's take it to be a, and it compiled. So as you can see over here, it resulted in 1. Why is that? Because what happened in the hierarchy of data types, char has a lower precedence than int. So in an expression, if one is of type int and the other is of type char, like here a is of type int and b is of type char, it's a character. So what happens, b gets automatically typecasted to integer, and what will be the value of b? The ASCII value of the character inside the quotes. Alright, and so that's what exactly happened. We had already seen before what happens when we try to print a character as an integer, and the answer is always, it results in the ASCII value of the character. Alright, and that's what exactly happened over here. Now let's try and make it a char star, a string. Let's see what happens then. And let's make this a character and let's put a number inside, 15.6. Alright, so as you can see over here, comparison between pointer and integer, so it gives an error because I'm comparing an pointer and an integer. Okay, so let's make it star b, so the value can be compared. Alright, so what has happened here is that the 15.6 inside as a string has been compared to the number. Okay, so we'll come into why it has happened when we study pointers. Alright, just if you can keep this in mind, that strings can be compared like this, right? Okay, so now that we have covered relational operators and bitwise operators and how we can compare values of two different data types, we'll be moving on to logical operators. Right? Logical operators are used a lot in conditions like if else, etc. Okay, so let's see. So there are basically 3 logical operators. We have the double ampersand, double pipe, and the not. Right, so these are basically used to compare two values or two variables or two expressions as well. Okay, so let's say we have a equal to something and b equal to 15.6. okay, so let's take the expression to be a and b. Okay, so logical operators can only strictly compare true or false values, right? No integer or data types. Okay, so let's see, a equal to 10 and b equal to 15.6. So this is the expression that I'm going to use for evaluation. So see how I've used the double ampersand. I'll explain what I'm doing right now as after I finish typing. Okay. B is equal to 15.6. Right, I hope I've closed all the brackets. Yeah, I think so. Okay, so let's compile that. Oops, I have an error. Oh, okay, I left b to be a char star. Silly me. Alright, so as you can see over here, what has happened is that there are two expressions in this whole expression. One is the a equal to 10, which means it's checking whether a is equal to 10 or not, and then we have b equal to 15.6. okay, so when I said that they only compare logical values, I meant true and false, but there are no identifiers as true and false in C. Alright, so we have 0 and 1. So logical operators strictly only compare zeros and ones that result from an expression. Alright, or they can also compare non-zero values and 0. Okay, so basically non-zero values also result in true in C, whereas 0 results in a false. Okay, so what has happened here is that, as you can see over here, a is equal to 10, we can see, and b is also equal to 15.6. so both of them expressions are true. Okay, so since both of the expressions are true, the result will also be true. Okay, logical operators, the logical AND is similar to bitwise AND only with respect to the output, not in which sense they will be used. Okay, while bitwise operators are used to compare two bits or two binary digits. Okay, I can compare whole binary digits as well with them. Logical operators can only compare zeros and ones, either 1 0 or a non-zero value. Okay, so let's move on. Okay, so a equal to 10 is true and b equal to 15.6 is also true. Okay, so since both of the conditions are true, the output is true. Okay, so what if I made this to be less than 10? Let's see what the output will be. A less than 10 is false because a is not less than 10, a is equal to 10. Okay, if I put a less than equal to, then it would have been true, but I'm going to make it false deliberately. So as you can see over here, the output is 0 because one of the conditions is false. Similarly, if we use the double pipe, that's the logical OR, it will be the same as the bitwise OR as well, except in ways of operation like I had discussed for the AND. Okay, so let's see. So as you can see over here, even though one condition is false, the other condition is true. Alright, so that's why it results in 1. What happens if I change the condition and make it greater than? Alright, so as you can see over here, since both the conditions are false, the output results in false. Forgive me for not changing these as well because I'm too lazy, but you can write down the program on your own and evaluate the expressions and see the results by yourself. Alright, so, and the last logical operator we have is the NOT operator. Okay, so let's check that out as well. Now the NOT operator is also used before an expression. It just inverts the output of an expression. If the output of the expression is a non-zero number, it makes it into 0, and if it's a 0, it makes it into a non-zero number. Basically what it's doing is that it changes true to false and false to true. Okay, so let's see what happens over here. Let's use an AND, logical AND. Okay, so what will happen is that a is not less than 10, right? So this will be false, this will result in false, but because we have the NOT over here, it will result in true. Okay, let's save that. So as you can see over here, even though a is less than 10 and this expression results in false, because of the logical NOT outside, this whole expression before the logical AND resulted in true, and the expression after logical AND is definitely true. That's why it resulted in 1. Okay, similarly if I use logical OR, then change this condition as well, make it greater than, it will result in 1 because this whole expression along with the logical NOT also results in 1. Alright, okay, so we have covered logical operators now. And now I'll be talking a little about ternary operators. Ternary operators are a kind of condition in itself. It's like a small one line if, except the syntax is a bit different. Okay, so we're talking about that now. So the way in which ternary operators are written is using a question mark and a colon. Okay, the expression, there's an expression before the colon, question mark, after the question mark, and after the colon. Okay, so let's write something. Okay, let's say b greater than 15.6 0. Okay, so let's just break down the expression that I've written over here. Let's put some brackets as well. Alright, so as you can see over here, what I've done is, it says a equal to, so clearly this is an assignment operator. Now let's see what happens on the right side of the assignment operator. There's an expression over here, b greater than 15.6. okay, so what is this doing is that it's simply checking whether b is greater than 15.6, and accordingly it will result in either true or false according to the values that we pass to it. Alright, let's use a scanf to take a user input, and you'll also see how scanf works. It's F and A, B. Alright, so as you can see over here, it evaluates the expression whether b is greater than 15.6 or not. If it is, a will be assigned a value 0, else it will be assigned a value 1. Okay, so this question mark means the expression before the question mark is the condition which shall be evaluated, and if it results in true, this value or this expression over here will be evaluated and assigned to a, and if it's false, this value or this expression will be assigned. Okay, here I am using values. I'll also use expressions to show what I am talking about. Okay, so let's save that and run our program. Okay, float star, double star. Oh, the printf. Okay. We'll be printing the value of a over here. Alright, so where's the output? It's actually waiting for user input. Alright, so since it's evaluating whether b is greater than 15.6, let's use say 15, and if you use 15, from the expression we can see that 15 will be less than 15.6, the result will be false, and hence a will be assigned 1. So let's see. Alright, now what if we run the program again and say let's put 20. Alright, so I had made a mistake over there. The scanf will be before the ternary operation. I was doing the operation before even assigning b any value, and that's why the output was coming wrong. Okay, so let's evaluate that again. Alright, so let's put 15, and that gives 1 because 15 is less than 15.6. the expression evaluates to false, and we get 1. Let's put 20, and as you can see over here, 20 is greater than 15.6, the expression results in true, and we get a 0. Alright, so the ternary operator is clear. I hope you can experiment with it. Let me use some operators to clear up the concept further. Let's take a plus b, not a plus b because a is not even assigned yet, so let's take 2 plus b. Okay, and if it's false, let's say 2 minus b. Okay, alright, let's compile that and see what happens. Okay, so if we use 15, it will clearly be false, and it will result in 2 minus 15, that's minus 13. Alright, and if we give 20, it will result in 2 plus b, that's 22. Right, So there goes the ternary operators as well. And I hope this was clear. The operators have been clear. I think I'll be talking about if-else in a separate tutorial of itself, because if-else has many things to be covered, many things to be explained, how if-else works. Alright, so hope you enjoyed this video. Leave a like, comment, subscribe. And another announcement I had, that I'll be away for a few days, so I won't be uploading videos up to 4th, right? I hope you guys won't miss me, and I'll see you in the next episode.